All right, this is the second video for Notes 82. We're going to start simplifying radicals. Now, you have been simplifying radicals for me, numeric radicals, since sometime pretty early in first semester. So if I just gave you, square root of 40, that was something that you did, okay? Now we're going to start simplifying radicals that clearly you can see they've got variables in them. So if I take a look at question number 4, part A and part B, basically what we want to look at is how can we simplify these, right? Because we're not dealing with numbers anymore. So question number 4, part A, we have x squared. Now, one way to do this is to convert this to a fractional exponent. So that is an index of 2. So this becomes x to the 2 over 2. Well, last time I checked, if I simplify this fraction, that's just x to the first, which would, just be x. Okay, and we've talked about in equations where if you have a square and a square root, they cancel each other out. All right, quite cool. There's an alternate way to do this, right? And it just depends on what makes you happy, which would be to say, all right, well, if we write this out as a prime factorization, this is what we've been doing with numbers, right? I'm going to change my color here. So if I deal with the square root of x squared, well, this would be the square root of x times x. Well, do we have a pair of x's? We absolutely have a pair of x's here. Remember, that pair will come out front. Whoops, right with pen. Pen, there we go. That pair will come out front. Anything that didn't pair up, well, everything paired up. But if it didn't, it would stay underneath the root. So whichever method you use, you're still getting the same answer of x. So let's see how we can apply that to part B here. And in part B, we're still dealing with a square root, but this time we've got x cubed. So if I take x and I rewrite this as 3 over 2, right, this is 3 over 2 is 1 and 1/2. I know that looks really weird writing it that way. And there's almost a part of me that's like, I don't like writing it that way. But what this means is that I have one whole x, and then I still have an x to the 1/2 power. So the 1 whole x, didn't mean to grab that, would go out front, and the x to the 1/2, well, that stays underneath the root. All right, it's kind of a weird situation, but basically, again, if I kind of change up here and I look at this in terms of the prime factors, you've got the square root of x cubed. All right, well, that would be the square root of x times x times x, right? X cubed is 3x's. So if we look at this, right, do we have a pair of x's? Yes, we do. So that pair of x's comes outside of the root, and then staying under the root is the single x that did not pair up. So again, whichever way makes you happy, right, work with that. So I'm going to go ahead and slide on over to part C and part D here. Part C, we're dealing with a root. Now we have x and y. Well, we're going to do the same thing. And it kind of depends on what you want to work with and how many times you want to write y out. But let's go ahead and, try the prime factorization on this one. So that means we've got 1, 2, 3, 4 x's. 1, 2, 3, 4, 5, 6, 7 y's. All right. Now be super careful when you're doing these pairs. We're going to have 1, 2 pairs of x's, then 1, 2, 3 pairs of y's. So if we collect this now, all right, how many x's do we have paired up? Well, we had 2 of them, so that's going to be x squared. How many y's do we have pair up? 1, 2, 3 pairs of y's, so y cubed. And what didn't pair up is going to stay underneath the root. Ta-da! All right. All right, let's do part D here. So part D, we've got the square root. Now this has a number in it, and we have variables. So let's go to town and see what's going on here. Off to the side, I'm going to go ahead and do the prime factors of 40, because unfortunately it doesn't mean I just get to write out 40 a whole bunch of times. Let's see, this is going to be 4 times 10, 2 times 2, 2 times 5. All right, so big old square root. I've got 2, 2, 2, and a 5. I'll put little dots between those. Let's see, 1, 2, 3 m's, 1, 2, 3, 4, 5, 6 n's. So let's see, what pairs up here? All right, I have a pair of 2's. I have a pair of m's. I have one pair of n's and another pair of n's. And oh, look, a third pair of n's. So collecting up all the stuff that paired up, I have a 2, 1 m, 3 pairs of n's, so that's going to be n cubed, and then the stuff that didn't pair up, I want to go ahead and multiply it all together. So 2 times 5 makes 10m, because we have a single m that did not pair up. There we go. All right, so that's the first part. Let's see what happens on question number 5. So staying in the same world of things, but here's the difference in terms of this time we're looking at cube roots. So if I look at the cube root of z cubed, 1, 2, 3 z's, and I cross mine so they don't look like 2's. So instead of looking at, when we were dealing with square roots, right, this index of 2, I was looking for numbers or things that paired up. Well, for an index of 3, I am looking for things that are in sets of 3. So I have 3 z's, so those can escape the root, and I just have a z left over. And it does make sense, right? This power and that index are identical, so they will cancel each other out, leaving just z behind. So for part B, if I wanted to do this, again, a couple of ways you can do this if you're dealing with writing out the root. So x, 3, 4, 5 of them. I'm looking for any triples, so sets of 3's. So there's my set of 3's. So that's one set of 3 x's, so that's x. And then I have the cube root. Please make sure that index is written in the correct location. And then what didn't pair up are 2 x's, so x squared. All right. I don't know why I just tapped that. There we go. So sliding on over, and I'm going to try and see if I can show you how to do this one without doing all the mess that I'm writing out. So I'm not writing out a whole bunch of letters. So this is, I'm going to go back and try to do the fourth roots here. And I'm going to write this as fractions. So m to the 8 over 4, y to the 3/4, and n to the 5/4. Okay, 8 over 4 I can absolutely divide, no problem. 3 over 4, that 3 is less than that 4, so there's nothing I can do here, right? 3 4's, and I would have 3 y's. I need sets of 4 to make it work. For n to the 5/4, this is the one that you actually can simplify, but part of it's still left over. Because if I take 5 divided by 4, it's not an even number. It doesn't go in there evenly. So we will talk about what's left over. So in this case, right, 8 over 4 is 2. Your y to the 3/4 is going to stay under the root. So I'm going to slide it over. My root is 4. That's going to be y cubed. Now, if I look at 5/4, how many 4's are in a 5? Well, that would be 1 4. So n to the first, or just n. And then there's 1 n left over. Okay. So if you had, and I can write it out, right? 5 n's. 1, 2, 3, 4, 5. And for a fourth root, right? This is a root of 4 here. We would be looking for sets of 4. So there's 1, 2, 3. There's a set of 4. So that set of 4, one of them becomes that n out front. And then this n here, the one that's left over, stays underneath that fourth root. All right, part D is the last one here. I'm going to go ahead and use the fractions again, see if we can kind of work through that. So this is going to be x to the 12 over 5 and y to the 7 over 5. So how many times does 5 go into 12? It goes in there 2 times. That would be 10. That's an index of 5. And then we would have 2 left over. Okay, so 5 goes into 12 2 times, and then 2 is left over. How many times does 5 go into 7? That's 1 time with 2 left over. So that is what you got. Now, of course, you can write it out, right? A whole bunch of X's, look for those sets of 5. A whole bunch of Y's, look for the sets of 5. I don't really care which method you use. What I would be careful about is if this was, I don't know, something ridiculous, like, you know, instead of 12, if it's 38, I would not necessarily want you to write out X 38 times. You can, you can. All right, so this is where the video is going to end for this part. I think this was Notes 82, but it was all about simplifying radicals. Let me know if you have any questions or concerns, and I'll see you in the next one.